So we can start, no?
Yeah.
Just wait for a minute. It's
Yeah.
already started. It take 1 minute to.
Yeah, started, I think. Live also started.
Yeah, Prasad. Now you can go.
Start, no?
Yeah.
Okay. So good evening to all the esteemed members of the Ocean Society of India, ladies and gentlemen. The Ocean Society of India is conducting invited talks as a part of the webinar series once in every month. And as we know that this talk is arranged from eminent scientists, engineers, academic professionals working in the broad areas of atmospheric and oceanic sciences, ocean engineering and technology. And this webinar is mainly targeted for students, researchers, scientists, engineers, and working professionals in the broad area of atmospheric and oceanic sciences, ocean engineering and technology disciplines, with a motive to impart and improve the knowledge that is benefiting the scientific community. So I request all the members to actively participate and get involved in all the lectures under the webinar series that is held every month, once in every month. So on behalf of OSI, it is my proud privilege to welcome today Dr. Basanta Kumar Jena, Scientist G and Project Director at NIOT Chennai, for this invited talk today. So Dr. Basanta Jena will be delivering a talk on the topic Progress and Prospects of Hydrographic Surveying Technology in Research and Development. So which is a topic of relevance for scientists and engineers working in the areas of oceanography, ocean engineering, and allied areas. So Dr. Basanta Jena completed his master's degree in physical oceanography and doctorate in marine sciences, oceanography from Berhampur University, Odisha. He worked as a research scholar at CSIR, the National Institute of Oceanography, Goa, from 1993 to 1998. And thereafter he joined NIOT since 1999 and presently holding the position of Scientist G and the project director. So Dr. Basanta Jena was very actively involved in establishment of coastal observation systems along the Indian coast, including the Andaman Islands, under various plants and industrial projects. So as a member of NIOT Coastal and Environmental Engineering Group, he has been quite instrumental in the establishment of the coastal high-frequency radar network along the Indian coast. 5 pairs of 5 megahertz and 1 pair of 12 megahertz systems are continuously operated under this program. And he played a major role in the hydrodynamic and sediment modeling studies towards the construction of the Kalpasar Dam across the Gulf of Khambat, which is an ambitious mega project under the state government of Gujarat. So Dr. Basanta Jena is a panel member and reviewer for many scientific journals such as Current Science, Ocean Engineering, etc. And professional bodies and technical committee members of different organizations under the Ministry of Earth Science, other state and central government organizations like ICJMP, the Central Water Commission, the Indira Gandhi Center for Atomic Research, etc. So he is very actively involved in numerous industry-sponsored projects related to the marine and coastal development works. So he has published more than 50 scientific papers in reputed journals and conferences. He has authored about 11 books and manuals, 69 conference proceedings, and 179 technical reports. So he was involved in 35 marine and coastal ocean observation projects, 20 bathymetry survey and engineering investigations, 75 port and harbor projects, 20 sediment transport, including coastal engineering design, creek and inlet dynamics project, and 25 coastal zone management project. So he has guided many students for their project work and actively participated in several invited talks and training workshops. So his research interest covers wide areas such as the coastal and ocean observations, the bathymetric survey for the exclusive economic zone of India, the high frequency radar, which includes both surface currents and waves, the shoreline management plan and policy making, wave, tide and current atlas for the North Indian Ocean, coastal sediment transport observations and modeling studies. So presently he is the General Secretary of the Ocean Society of India from 2020 to 2022, and he was awarded the Certificate of Merit for his outstanding contributions in the field of ocean science and technology in the year 2012 by the Ministry of Earth Sciences, Government of India. So with this brief introduction, it is my proud privilege to kindly invite our speaker, Dr. Basanta Jena, to deliver the talk. The participants are requested that the questions and answers will be attended after completing the talk. So please feel free to put questions in the message box for the speaker in the chat box. Thank you very much. So I request now Dr. Jena, please, to deliver the talk. Thank you.
Thank you very much, Professor Prasad. And first of all, I thank the President of OSI and the Governing Council member of OSI to giving me this opportunity to talk today in this OSI webinar series, monthly webinar series, which is very well conducted without fail every month with eminent scientists and researchers of this country. And today I am here to present in front of you about that the latest progress and prospects of hydrographic surveying technology, which is a benefit for the research and development work of our research community. So with this, already Prasad has introduced me. Any questions you please put, or you mail me afterward also, so that we can have some details. So I hope my slides are visible, and so Prasad is changing to second slide. Yeah.
Yeah, it is visible. Yeah.
Yeah.
Please, visible.
So my presentation of outline I have made like this: the introduction and survey planning. Then after survey planning, what are the eco sounding systems are available, like multi-beam, single beam, LIDAR, unmanned satellite, and then satellite things. Then topography survey using RTK, and subzone bathymetry survey using AUV, UAV, and water scooters, etc. Then apart from this, we require this surveying the additional parameter like tide, currents, waves, temperature, salinity, and SVP. And for this, we have to have a better control survey. That is, we have to have this either with respect to CD or MSL. Then how we are going to derive this. Then onboard operational equipments, what are the equipment set we have to select. Then how we can do the calibration of the equipments to get the good quality data. Then how we can generate this hydrographic maps for our various applications. So with this, what for this hydrography survey is required? And why we should do this survey and how to do that is the basic talk of the today. So mapping of on-road topography pertaining to sea, lakes, or stream and any other water bodies, including the coastal, nearshore, and offshore, is called as that we have to do the hydrography survey. And it defines the shape of the topography which is beneath the water surface. Then why it is required? It is required for various applications like navigation charts, with respect to chart datum or MSL, then planning of design, construction, and maintenance of a harbor, then exploration of a seabed, management of research, then the demarcation of HTL, LTL for the CRZ applications. Then this in brief, just I have put here that the different types of maps which is available with very coarse resolution and high resolution, which is required for our modeling. So like that mapping of nautical charts that is NHO is doing. But for our research and development application, we required a different type of bathymetry with the high resolution. Bathymetry is required for that at least the coastal waters. So for that, what topic today I am going to talk to you. Then which is required for coastal zone management like CRZ, then inundation, flooding, coastal flooding, either from seaside or land side, which is very, very essential. Then development of the coastal infrastructure. Without bathymetry, you cannot do a fishing harbor or jetty or breakwater or anything. Then improve the accuracy of the climate change model study also. This bathymetry is the main parameter for any type of model you do for whether we can say as a coastal circulation or coastal inundation or sea level rise or morphological change. Anything you say, bathymetry is our basic parameter. And if you get that good quality bathymetry data, our model will be predicting a better accurate way on our results. So coming to this, doing the bathymetry survey, we have to have a meticulously the better survey planning. So in that, I will tell you in detail, we have to have what are the area to be surveyed first. So our coverage area, what is the area to be surveyed? That has to be planned and marked properly with all the angle. Then in that area, what is the tidal range? What is the current speed and direction? What is the wave height and weather condition in that you are doing of survey? Because these are the weather planning which will be also required, not directly but indirectly for your to get the good quality data and to reduce your cost and time benefit. Then coming to this your line planning. So which line, which direction, whether northeast direction or southwest direction, which line you want to plan. Basically, this is orientation should be done by that coastal inclination and the site to site this line planning will vary. And also, which is also you have to do as per the ISO standard. If you are doing a vertical line of 200 meters, then 5 times of you have to do the cross line or tie lines. Then as selection of the suitable manpower like a hydrographer, survey engineer, and like instrumentation engineer, etc., where we can reduce the downtime and get a good quality data. Then various equipments. So a lot of equipments have come in market, but which are not suitable for the survey. We can give the data, but that is not suitable for the survey grade ecosound. So we have to take the survey grade ecosound or MRU, DGPS, which is the better accuracy and high resolution data gathering systems. Then coming to the suitable vessels, we have to put in place because bigger, say, some vessels are suitable for offshore that cannot be used for nearshore. The nearshore vessels cannot be used for subzone. So these are the things we have done. As I told you, if you are going to this survey, let us say this is I taken about the South Kerala coast. So one day we cannot do it. So we have to have the box wise, which box we have to plan and which area we have to plan, how many days to be taken and what are the things we have to consider things. So accordingly, as I told, we have to do the line planning. This is the vertical line and this is the cross line. So as per the IHO standard, we have to go 5 times of the vertical line to cross line ratio. Then coming to this, just what is echo sounding? Echo sounding, actually, you know that seawater is bad conductor of light, so, and also the electromagnetic waves. So we have to do the depth measurement using the sound signals. So what we are doing is echo sounder is either echo sounder can be fitted in the hull mounted or the side mounting poles. It sends the sound pulse into the water and it reflects back after hitting the seabed. And we know the sound velocity precisely if you measure through SBP. That's why I told SBP and all these things are the additional parameter we have to have along with the survey spread. So we can estimate the time lapse between the measured depth going and coming divided by 2. And you know the sound velocity, then normally it is 1500 meter per second, but it will vary depending on your site condition of salinity, temperature, and pressure. So if you have the accurate measurement of sound velocity, you can reduce your error estimation of the bathymetry. So this is just one simple example I'm showing here, how this sound pulse goes and comes up, and it records in the either echo sounder or in the digital format in the computer itself. And this is that just a sounding operation as a small spread I have given here. That is after how we can install the boat, either side mounting or hall mounting, as I told. Then we have to have the detailed dimension of the boat, and where to because we have to give the offset for DGPS, offset for the echo sounder transducer setup, as well as we have to give the MRU, which is very, very important. Because when we are running the boat in the sea, it has a lot of rolling and pitching action due to waves and currents, and that has to be also applied for that depth correction. Then we have to have get the DGPS correction, because nowadays in all over Indian coastline, we have so many transmitters which transmit the signal through satellites, and our DGPS it receives and gives the accuracy. These beacon receivers are giving less than 2 meter accuracy, whereas now that some satellite-based systems are there, Omnistar and Seastar, we can get less than a meter accuracy, and some are high resolution like 12 centimeter accuracy we can get the depth operation. Then coming to this sound operation, we have to, as I told, we have to have installed the system on board. Then we have to cast the sound velocity in the seawater to measure. Then we have to have the offset between the echo sounder transducer and heat compensator and GPS antenna. All these things measured and fed in the software, data acquisition software. As I told already, survey line has to be plan such that we can in less time and less get more coverage. And then survey, then cross lines, as I told, it is 5 times of the things. And survey vessel has to be transferred without any much deviation in the survey lines. Then this is just I'm coming to that how the different parameters are affecting the depth things. As I told, one is sound velocity. Now second is also the depth error may occur due to this retraction of the seabed. And here I want to inform you that because this everybody thinks that if you go by echo sounder you can get a depth, but not the easy things all the time. Where our research and development work, we required a lot of consideration of the other parameter, like that was heating, precipitation during rain time, and wave-induced mixing, then phase water coming into the system, and tide and current variation, and upwelling also. All these things also having directly or indirectly impact on our that survey, that hydrography survey. If you see here, I given an impact how that sound variation, sound velocity varies with respect to the tidal impact and freshwater and seawater mixing. If you see here, if you not properly measure the sound velocity at this like estuarine and riverian places, so we will have a large variation of sound velocity in shallow water as well as deep water. And if you process with one value, you will have a wrong depth, which can be order of 2 to 3% error we can achieve due to sound velocity itself. And here I am showing one of the depth error due to improper sound velocity data. So it is taking time. So these are the things will come. And here I have put a set of vessels, how to tackle this bathymetry survey starting from say topography, the coastline, covering the coastline. So we planned to start the bathymetry survey, not only that from water itself, to consider the land. So we have taken the topography survey from +2 meter scale to 0 meter. Here 0 meter means not exactly 0, we gone little beyond 0.5 meter to 1 meter wherever possible. Then we done the subzone survey using this jet ski or unmanned vehicle. where we have given that RTK input from the base station so that the tidal corrections are error has been reduced. Directly we applied the MSL or CD from the RTK to echo sounder. So using jet ski, we are using the 0 to 5 meter. So 0 means at least 0.5 meter to 5.5 meter. So we are having each location overlap of each measurements. Then coming to this 5 meter to 30 meter, you are using a conventional boat. So with this, we are now able to cover from high resolution bathymetry data, starting from plus 2 meter STL to 30 meter, which is very, very important for our coastal researcher for any inundation modeling or storm source or cyclone modeling or flooding, etc. can be worked out. Coming to this types of survey so as I told now, so it's a single beam echo sounder, which is very, very useful for the shallow water, like starting from 0 meter to 30 meter, because there, if you use the multi-beam, we cannot get the coverage and there is no benefit out of that. And second is multi-beam echo sounder. Parametry echo sounder, I'll come details in one by one where we should use which echo sounder. Then LIDAR, then unmanned vehicles, satellite imagery, topographic using RTK and the total station and the automatic station, sub-zone using AUV, UAV and water scooter. Which is this in nutshell, I am putting single L multi-beam echo sounder. Here you can see these two pictures. So how it is gives the variation and also the light detection range LIDAR systems and satellite observatory. Then we are using also bathymetry intertidal using the topography survey and sub-zone survey. So and this is that parametric echo sounder we have developed, and we are having this UVB we are using in a lake survey and the still water and the nearshore survey also. Then this is the things, and this is the outcome of a single beam, and this is the outcome of multi-beam survey. Basically, single beams can be used for this any shallow water survey or any nearshore survey or lake survey, which is very handy to use. And the single beam echo sounder also nowadays come with high resolution data covering like say in 1 second 30 value or 20 value or 30 value, even 50 values has come, like 50 hertz sampling rates. And it has a single frequency like 200 or 210, as well as that it has a dual frequency which can be used for our sedimentation study. Is a 210 to a 200 or 33 or 210 by 30. So these are the frequency are used for the single beam echo sounder. And single beam echo sounder can be used in either a hull mounting and side mounting. It can also use in small boats like water scooter, canoe, and even you can go by hand and per spot sounding also. So these are the things are there. This is some of the equipments of a single beam echo sounder, which is a dual frequency. This can go up to say 0.3 meter water depth to 100 meter. And this is the portable echo sounder with the same capability. The Pulse and the Seducer Pro. Similarly, we have a Wellport and so many other companies. We have a echo sounder. And coming to multi-beam is instead of a single beam, we are getting only one ping. Here we'll get more than 100 pings. Sometimes nowadays multi-beam having almost 270 degree inclination, so we can cover a wide area. So that less time we can cover a large coverage. But it is not suitable for, as I told earlier, for the shallow water survey. This is some example of the multi-beam echo sounder. This is the transducer, and it requires the continuous sound velocity profiler input, as well as the profiling of the sound velocity. You have to give an input to get a good quality data. And we can generate this DTM, the digital terrain model, using this multi-beam data with a high resolution chart can be prepared using this multi-beam survey. So where these are useful, like now any pipeline survey or a port and harbor dredging survey and all, this will be very, very useful. So this I am showing one dredging work which we have involved in using multi-beam and single beam. So basically we suggest for dredging, go for a multi-beam survey. And this parametric echo sounder, this is a very good tools nowadays has come up, where we are not able to approach with any of the shallow water for the subbottom propeller. So any subbottom propeller, we cannot come less than 10 meter or 5 meter. So 5 meter to 0 meter, you want to have still your soil strata characteristics. Better to use this parametric echo sounder, which will give depth as well as that will penetrate also summit. This can be only very low frequency, the high frequency, 100 or 110, only difference up to 10 kilowatts. It will give low frequency to high frequency, only 10 watts difference. It will give that your soil strata information, what is the buried into the object, 3 to 4 meter penetration can achieve by this. So this is just a bathymetry mapping tool starting from the shore to deep water. So if you see here, shore, we can put a tide gauges, and these shore things can be done by, as I told, with a small vessel or RTK or airborne system like LIDAR and all these things. When we go deeper and deeper, we can use the seaborne based things or spaceborne bathymetry also is nowadays acceptable. The JEPCO and all people are using the model for deep water. Coming to this, we are now trying our system to have that coastal survey, because the coastal is a dynamics, 0 to 30 meter is a dynamic, everybody know, and 0 to including subzone to 10 meter water depth is very, very dynamic. So we have to have a frequent survey, but at present available system like single beam echo sounder and going to site and doing, it takes years of time, couple of years, 2 to 3 years of time to cover east coast of India. Whereas this type of system nowadays is coming up with the proven things. So far in India, we have not used it so far. On trial version, we are trying with the US, but US and Europe, they started and frequently they are doing that subzone survey and nearshore survey using this technique. And here we depend on this very clean water. This can go up to 60 meter depth. And this is capable of starting from land to water. And if turbidity is very high, we can reach only 4 to 5 meter water depths. But if you have a medium turbidity, 21 meter we achieve or 15 meter we achieve, it is good for us to have a frequent survey so that we can reduce the time, and money also is if you do purchase the system and we have our flying system, it will be cheaper than that and time saver from the multi-beam or single beam bathymetry survey. Now coming to this topography survey is using RTK. Earlier used to do through that say manual using that automatic level or total station, which is taking the time, and transferring the datum from GTS benchmark to here was taking long period. So presently this RTK system was very handy, and it is user friendly, which works with the satellites based systems. And so nowadays we are using for bathymetry also this RTK input, so that tidal corrections are not required in future. As I told, we have developed some of the UVV, that is the for the shallow water automated unmanned bathymetry vehicle. Here we have made a automatic system where we can able to get bathymetry. Not only this, we have put echo sounder, we have put a ADCP as well as the water sampling device where automatic where we are not able to go. You can program it and it will go take the depth, and the same depth is achieved, it can collect the water sample and come. So this is the advantage of this system. And another things, when earlier subzones bathymetry, very few locations are measured by wave slides, which is very tedious, and non accuracy level is plus or minus 20 centimeter. So to save the time and money, we have done that integrated survey system using jet ski and single beam echo sounder with dual frequency and RTK input and MRU, everything integrated successfully. It is demonstrated at Tamil Nadu, and now we are going for other states. And coming to this, before this sub-zone that jet ski, we tried several methods. So one after this conventional wave slide, we have done also wave slide putting this pressure sensor in bottom and top is the GPS floats. So that also given a reasonable good quality data, which is matched with the that conventional things as well as the echo sounder. So these are the things we have tried before settling for this jet ski for better for the survey. One more things when we are doing for the beach profiling survey and all these things using to automatic level or total session is taking time. So there we are now using this called leader instruments. You can set up the beach. It can scan either side of the 1 to 2 kilometer depending on your site condition, and we can analyze and we can get that accurately the beach profile variation. And as it is the coverage is more in less time and the things, you can do the more number of kilometer survey using one go. Apart from this, now the development also has come that using high resolution satellite imagery to estimate the depth profile. So we got an opportunity to work in Gulf of Cambodge as well as the Bellingham coast. So the Bellingham coast every 6 months we are using getting the data. So we got some satellite imagery. Then we made a methodology how to derive this bathymetric data from the satellite imagery, and we derived the bathymetric data from the satellite imagery, that is band ratio method. And after that, we validated with the field bathymetry profiles, and we got a reasonable good data. And we have also published one paper, and we are working towards to improve more. And apart from this, what I told so far about what are the types of different types of hydrography survey equipments and all these things, how to do it. Apart from that, we have to have a tide measurements at a different location in your coverage area. And currents, it is no need to measure the currents, but you should know about the knowledge of the currents for your movements. Temperature salinity is must because it depends on the sound velocity varies on the density, temperature, and salinity with respect to depth. So we have to have a sound velocity profile with respect to depth, and we can reanalyze the data in processing stage itself again if required. Coming to this survey datum is called as a control survey or vertical control. This is very important to have it because all this hydrography survey, the bathymetry data has to be connected to either MSL or CD datum. So as you know that Survey of India has kept on the GT benchmarks all along the coast, and we have to bring that area to our study area using various methods, either RTK or some conventional method with the accurate manner. So this is what I told, and now we are using this GPS technology to bring these GT stations referred to our survey. And we are using this for the tide and beach profiling and bathymetry data. So, and this MSL to CD difference is basically this Survey of India benchmarks are come as a reference to MSL, and we adopt this NHO survey charts from converting that MSL to CD. And accuracy of the survey datum can be achieved even 0.1 meter for the using, if you are using this GPS static mode, we can get a better accuracy of the survey. Then coming to this, if you don't have this datum, then we call as a sounding datum. So that if you don't have any other datum to correct, you yourself can arbitrarily have your tidal measurements and you can fix a depth of for your sounding charts. Then we call as a high tide or a high water. This is the water level during the given tidal cycle expressed in the feet or meter related to sounding charts. And low tide also similarly. Then range of the tide is from this low tide to high tide difference is called the tidal range. So this is just one figure, just I'm putting here for the chart datum and water level variation, how it will impact on your vessel movements. And this is the things, the reference datum. You see that in the right side of the figure, this is the low water line and chart datum. Then coming to the mean sea level and the high water level, then limits of the drying height, that water can go up to low tide line. And geodetic line is our reference to MSL, and the hydrographic of the shoreline is called as a high tide line. And this horizontal is we generally use this WGS 84 for the DGPS and all these things. And for vertical, we use mean sea level, and which is better for our any modeling studies. Because chart datum is varies from place to place, whereas we can uniformly use this mean sea level from North Indian Ocean studies. HAT and LAT, which is a height related astronomical tide. This is the highest astronomical tide called HAT, which is the highest level, and the lowest astronomical tide is LAT, is the lowest level, is expected to occur in the average meteorological conditions. Means that is we consider as a 19.5 years or so. Then mean high water spring, which is that highest height we get a successive during full moon and new moon time. But every time the new moon and full moon, this mean high water is varies. That's why mean we call. So both average it is put is called mean. Similarly, mean high water neap during the neap, which is the first and fourth quarter moon is called neap tide. So both tides, as I told, it will be different the heights, so range. So that also again averaged. Then mean sea level is called as average of all stage tide for 19.5 years. And then similarly, we call as a mean low water neap and mean high water neap. So here, if you see the in India, the classification of a tidal range is just we have put in the microtidal, mesotidal, and macrotidal range. And microtidal range is less than 2 meter, and mesotidal 2 to 4, and macrotidal more than 4 meter. So our Gulf of Kutch, Kambat, and Sandheads are having more than 4 meter tides. And as I told, this data will be very, very useful for marking the STL, LTL, and hazard lines, and our marking this EZ survey and all these things. So coming to this oceans, that actually this is useful for this our exclusive economic zone. So we are also part of this survey. So this is the classification. What I'm showing is this is the no nautical rights is more than 350 miles from the coast, and which is called as a continental shelf margin, last things. And our exclusive economic zone is up to 200 nautical mile from the coast, and this 12 nautical mile is called territorial water. So now in MOVS, we are doing this survey for entire EZ, including shallow water and deep water. So it was now done by various organizations, and this data goes to the Marine Geoscientific Database, where NCPR is the nodal agency, and they are also doing 500 to beyond up to the continental shelf. And NIOT has assigned to do this shallow water survey, that is 0 to 500 meter per east coast, and NIO is west coast, and GSI also is helping in this. So the data effort is utilized by various people and various work. That identification of the major topography and geomorphic features in our EZ, and geological hazard assessment, mineral resources and petroleum and natural gas exploration, fishing community, then site study, construction and mining and offshore structures, etc. And waste disposal, site study, all these things. This data is a vital parameter for any type of study in coastal waters or on offshore waters of Indian coast. And where I am involved in this presently, this bathymetry hydrography survey is from +2 meter STL to 30 meter. And for east coast of India, we have completed that 100% West Bengal coast, covering up to 30 meter on the sand heads. Then we are now doing the Odisha coast survey. Andhra Pradesh has been completed almost 40% of the coastlines, and up to Kakinada and south. And Tamil Nadu also we have completed from Krishnapatnam to up to Rameswaram, including this pathway. And we are going to complete this work maybe this December 2022. And this is the progress of the work. As I told you, we have completed 70% of Tamil Nadu coast, 100% of West Bengal coast, Odisha, and the rest of the work at Tamil Nadu is under progress. And this is the some site photos during the topography survey, how these people are going into the water, and after setting up the RTK base is shown here. This is the real time all teams are working at various sites. Then here I want like to tell you that how if chart datum is not there, then how you can establish a datum for your survey or for your requirements. So establishing chart datum for your survey is very, very important. If you are not having your datum at this stage, it is because there is two types of you can do. One is we require to measure a tide for 19.5 years, so which is not possible by us. So we can transfer the location. If you know a CD at one location, we can transfer to our required location at B. So we have to measure a tide at simultaneously at A and B, preferably during the spring tide, and reduce the level from A to B with the following methods. So I'm showing one method here. So if you measure the tide simultaneously and basic, you have to make sure that you are measuring the tide during spring tide. It is, I think, this is the spring tide time. What is the variation? You can put this like spring tide 2 days. You can take A, B, C, D, E, F, G, and then there is a formula to compute that mean water level and mean high water level, and that mean water spring, and also mean high water spring, mean low water spring, etc. Then there is a datum of B also can be estimated. D, there is using this formula. It is just given here, and so this is the formula which we have given here. And so with this formula, we can derive the MSL to CD different at a given time. So this is the things. It is, yes, so this is the things. And tide observation can be carried out by various means. That is manual, putting the manual tide poles. Like earlier days, we used to use the tide pole with the marked every 5 centimeter or 10 centimeter each. But later on, it developed to pressure gauge, pressure sensor. After that, also pressure gauge with that vented tube for correcting the atmospheric pressure, because pressure was giving again loaded with atmospheric tide. So that has been rectified. After these float gauges are the good, but it required the infrastructure to be installed on any that jetty or harbor jail. We required this some infrastructure problem. Now this some of the tide gauges are come remotely, that is called RLS, and the bottom mounting pressure sensors, etc. But for important, you have to keep in mind that any tide measurements for bathymetry survey we are doing is frequent as we can measure. The interval should be 10 minutes or less. 6 to 10 minutes interval is very suitable for getting a good quality tide data, as well as that to be useful for reducing our chart datum or reduced to depth from the hydrography survey. Why I told tide measurement is required during the survey is when you do the prediction tide, we cannot able to make 100% tide measurements where the tidal ranges are very high. So we had one project called Pulpusar. There, when we did the survey, and we are found very difficult to apply the tide correction and get the good quality data of bathymetry. So there, with our experience, we have now put every 25 kilometer one tide gauge location. Then we developed a co-tidal model for entire Gulf. Then we generated a tidal constant at each points, and we have applied the tidal correction at each point of the depth. So that's we could able to achieve the good quality data of that area, even though tidal range is more than 13 meter, and that current is very, very high. Based on this data and experience, we have developed a tidal atlas using that. Even we put this Android applications like this. Anybody can type your Android Play Store that North Indian Ocean Tide. You can able to download and install with your username and password. That once you install, you can click anywhere, not only the coast, you can click anywhere inside also. We will get the tidal prediction for next 2 days. So present day and 2 days. So 3 days tide will get with the high tide and low tide with time, date and time. So you will get like this. And also what is you might have seen this top portion, no? We are not able to predict the river portion because it is not having a proper tide, that sinusoidal tide. So I'm coming to this what are the equipments are required for operational purpose. So that region, so I'm just doing this, showing you what are the equipments we should select for this onboard operation. One is, as I told, EcoSounder, then laptop with data acquisition software like IPEC and other things. Then one more, you have to give a Halsman display monitor for the captain to see and drive on the same line planning. Then navigation system like DGPS, then communication system UHF, VHF to communicate with others. SBP, sound velocity propeller, MRU, then data acquisition software. All these things is required. And some of the equipments I'm showing here, this is the DGPS, and this is the RTK system, and this is the portable EcoSounder. And coming to this, some of the more setup, we have to have a DGPS receiver, and all offset, as I told you, have to give properly to get a good quality data in your high-tech software or other equipments. Coming to this quality control, so we have to have a certain procedure based on this IHO standard. We have derived one standard operating procedure for saltwater bathymetry survey, where I am putting here all these things. So we have done this to get a quality assurance in putting suitability of equipments. Because this is very, very important. You have to see the equipments which is suitable for your survey and also give you the good quality output data. Then calibration of equipments. We have to do the calibration at the lab, as well as when you go to site also you have to do the calibration using bar check or lead line, etc. And then reference check or integrated check is required, and data logging from different formats also is required. So the standards we have derived, and we have brought out a standard operating procedure for a single beam EcoSounder, It is published at NIOT internal record. We will be publishing in outside in future recently. Then bathymetry survey position that eco sounder, DGPS, MRU, then tide, boat and vessel parameter, bar check, lead line, vessel draft check, sound velocity profile, data acquisition check. Then the topography survey, we have to check the position, calibration of the equipments, benchmark establishment, and data acquisition. So all these things we have brought out how to do and when to do. All these things we have brought out very nicely in that standard operating procedure. Then quality control plan includes the following: the checklist for the boat and other vehicles, platforms used for the bathymetry survey, and checklist for the eco sounder, MRU, DGPS, SBP, and CTD equipments, checklist for the topography survey, checklist for the base station rover. So these are the verification we have kept for the party chief or the team leader at the site, verification of the coordinate system, equipment check and in the field, verification of integrity check of the equipments, verification of the offset details on board, that and the draft of the vessel on daily basis, verifying the SBP casting and applying into that eco sounder, verifying the equipments entire during the acquisition time, verifying the log sheet and transferring of the data from field to lab. And lab we also check for the checking. Similarly, we have done various checks for this topography survey. And here in NIOT, we have set up a processing team, and there also we have kept that various checks for the processing team itself. So bathymetry survey processing, first of all, they will arrange site-wise bathymetry data in proper data structures, and then converting the water level data during the survey period to the tide by using this data, removing the spike sounding using bathymetry survey software, checking and applying of the offset parameters, converting the raw sounding, depth sounding, and applying draft, tide, etc., if correction and all. Then cross-check the sounding difference between the cross-line statistics and need to be generated blockwise. So, because if you've taken a very big area, then you have to split into the blockwise. Then converting depth sounding to desired sorting and specified by that our NIOT. Then application for measure sound velocity, either we can take from CTD or SBP, and generating the charts in blockwise or requirement by the clients. So these are the things we have made a metadata for raw data set. We have made a certain procedure to be followed, and all these things are documented so that today, if a party chief is not available also, this data can be retrieved in the future also. And anywhere any error occurred, if you maintain this type of data set, you can reprocess or reanalyze your mistakes and correct it once again. Similarly, we have put the metadata for processing data set. Similarly, here we have followed the certain norms, and that is meticulously followed by our team, either field or lab. And we also generate the daily progress report called DPR from the site as well from the lab by some manual as well as digital format. After that, when we do the processing of the survey, we also check how best we get the data, where we are matching. So for that, we do the cross-line statistics. So there, 95% confidence level matching with the IHO survey standards derived is matching or not, we are checking. So like that, you see here, that's cross-line and sub-line matching between 10 centimeter or less than 20 centimeter. So like that, we have checked with different survey boards, which is also matching in different times. That also is done. Then finally comes to the chart preparation. So chart preparation done like that. Then we are putting a legend here who has done that like this. All the notes we are putting in the charts. So it gives a site location where the chart comes. Then who are the persons involved? What are the datum is used? What is the zone has been used? So then all this notice we are giving. Then finally, one sample charts NHO I have put here. So we are just doing as the similar manner, but we are confined to very 0 to 30 meter now, and also we are having a high resolution data. And all data are in XYZ format, we are in ASCII format, where anybody can use this data. So this is the survey IHO standard IS 44 we are following, which is 2008. In the 2008 earlier only two order was there. Now they made a social order and 1A, 1B, 2. Then now recently they have revised again to order 2, order 1B, 1A, social order and exclusive order. So we are falling under this 1A or social order, which is recommended for this shallow water and subzone survey. So coming to this standard, I have put here how you can estimate your standard based on that NHO or IHO standard. This for this positioning accuracy as well as the depth accuracy. So you can use this formula and you can derive how best your data is. And this data, as I told, it has a various application. You can use this data is port and harbor and navigation studies, pre and post dredging survey, siltation studies, and then SBM deployment and planning, pipeline routing, NHO charts and their features, STL, LTL marking and CRZ mapping, coastal process, inundation mapping and modeling, and ASCII data sets for modeling people. Some of the applications just I am putting here, how dredge disposal study are done with this type of bathymetry survey, because any model you have to first have input parameter is the bathymetry. And how this dredge, once you deploy anything into water, whether it is a functionality check by using this type of hydrography survey. So one example I have given, we have done in Haldia river. After deploying the dike, how the dike is a variation. We have every week we have done a periodical bathymetry survey and we have derived this type of things. And if you have also periodical bathymetry survey, you can study better in this sedimentation deposition work. So if you see 2006 to 2010, we happened to study same time the bathymetry survey, and so that we could able to derive the sediment deposition in that port of Pipavav channel, and how it will be helpful for the maintenance and port planning purpose. Similarly, we had one more opportunity to monitor for a long period at our Chennai CPCL jetty. Depth has been varied due to sedimentation, and we have monitored almost 9 to 15, 2009 to 2015, 4 years. And we followed all the standard procedures so that our accuracy level has been maintained. Coming to my last slide, I will keep that hydrography survey benefits. As I told, it can be used for the resources exploration like fishing, mineral, etc., environmental protection and management, maritime boundary delimitation, national marine and special data infrastructures, and then recreational and boating purpose, maritime defense and security purpose, tsunami, flood, inundation and modeling, coastal zone management, tourism, marine science, and circulation studies and modeling, etc. With this, I thank you very much for giving this opportunity and for listening to my talk.
Thank you, Dr. Basanta Jena. You have touched upon a very important topic and a subject of interest for oceanographers, ocean engineers. In general, for almost all the marine related activity, we require bathymetry, and bathymetry is one of the fundamental parameters that is required for any modeling studies or any type of process-based studies. So your presentation was really very nice. You started with survey planning, covering aspects of echo sounding principles with single beam, multi-beam, LiDARs, unmanned satellite topography with that specifically on the RTK and on the surf zone monitoring. Thereafter, you had covered the parameters that is being collected during the hydrographic survey, which includes the environmental parameters like tides, currents, then temperature, salinity, etc. You had also covered on control surveys, especially the datum and MSL, the mean sea level, onboard operations and equipments, calibration issues. These things are actually very good. Actually, I've discussed on that. And finally, you have touched upon the hydrographic maps and the applications of these studies. You are also covered on the tidal atlas development, which is a very important work that NIOT has carried out. And it's really good. I think it was really very interesting and very informative talk, which will be, I'm hopeful that it's very important for all the studies actually, because a very fundamental parameter which is required for all the oceanographic applications. So now let me look into the chat box if there are any questions that have been on the, yeah, so there are actually some very good remarks actually, very nice presentation. And let me see if there are any questions that is put on the chat box. No, I don't find any questions on the chat box, but I have actually noted down some few things like which I would like to get some information from you.
Yes.
So the bathymetry mapping tool that you have mentioned, no? You have mentioned about a mapping tool.
Yeah.
So does it actually account for the varying water levels? That is, the tidal impact has also been taken care in this mapping tool.
Yeah. Yeah. When you go for subzone and say 0 to 5 meter basically, there now if you do conventional way of putting ecosonder in a boat and going now, so that what will happen due to the waves and the shallow water, and we cannot measure the tide at shallow water. That
Exactly.
very difficult at that age. So what we did is we have put a base station at shore, which transmit X, Y, and Z value.
Yeah.
So directly that Z value goes to into the, that is Z value nothing but your the reference level that either MSL or CD. Basically, we take MSL into directly your echo sounder, so that tidal variation, tidal correction is not required for that. That's why we made it as a tool. That's why we call it a tool. So that package is consisting of echo sounder, which gives the depth, MRU, which gives the roll, pitch, and motion of the vehicle, and tide. Directly, the RTK tide has gone into that. So that's why it got.
What will be the cost of this RTK system actually? RTK system?
RTK system is now around 10 lakhs to 15 lakhs, depending on the your different makes, you may get it.
Okay. Okay, in one of the slides, you are actually mentioning about the satellite imagery imageries and the remote sensing application. So up to what depth actually this can be used? Up to what depth?
Yeah. Actually, nowadays we are very much only people are interested on subzone, because so far in India, in bathymetry means we come up to 5 meter only, or if you are using little bigger vessel, it is 10 meter only. So 10 to below meter, we don't have basically a data. So our main intention is and using this water scooter concept and using the tide. Recently only we have last 2019, I think we succeeded. We trial first with pressure sensor with top up GPS and all these things. We have done some hit and trial run for 3 to 4 options. Finally, we stick to this. This is giving some progress, like per day, you can work only subzone 2 to 4 hours only if weather is calm. And output is very minimal. You 20 kilometer line kilometer you can cover. Means 20 line kilometer means only the length, if you see the coast, maybe 2 to 4 kilometer only. So entire coastline, east coast is 2,500 kilometer. So we cannot cover. So we are thinking alternate, like I shown you that one is satellite imagery, second is LIDAR technique,
Yeah.
So leader technique, we can come if you calm weather up to 15 meter water depth only. India, we have tried all these things. But as you rightly pointed out, for satellite imagery, we are getting good correlation up to 10 to 20 meter also we are getting. But now we given only two sites. One is Kerala, one is Gulf of Camber. We are now trying little more runs because Kerala we are getting every 6 months data. So we are doing now. Maybe I can come out my research maybe some another 6 months time. Whether we can able to get see our interest if you get 10 meter you are safe actually. That our target is 0 to 10 meter we are targeting.
Okay, that is very good. So I think there is one question from the chat box. The question is by Dr. Keshav Das sir actually.
Okay.
The question is, was the bathymetric survey done by NIOT directly or through some agencies?
It is directly or that agency actually we gives data collection. We have set up our methodology by NIOT, what I shown to you. We gives the data because you know it is a very long coastline and we gives to them, but data processing lies with NIOT. Data quality control we have keep our quality control and quality assurance team along with their agency in a boat as well as in the topography survey and processing everywhere we keep our people for quality control.
Okay. Yeah, the next comment is by Ram Prasad Tamiseti. So the comment is very concerted effort to generate a gigantic amount of bathymetric data with the highest possible quality measures. It's a great effort by Dr. Jena and the group of scientists associated with the effort.
Yeah, thank you, sir.
Yeah, and one more comment is there that is from Mohammed Shafiq.
Okay.
Can this bathymetry data be used for storm surge modeling?
Yes, very well. It is a very accurate. Actually, I will tell you now we are in the acquiring of the data. We have submitted our database, as I told NCP or Goa, Geoscientific Data Center. Once they approve, because dissemination lies with NCPOR, then it has to, because it is a very high resolution data, it has to be, they have to approve and they have to disseminate guidelines, they have to prepare, then it will go. And I can say that it is very, very useful for any modeling purpose.
Yeah, that's fine. I think one more is there. One more question just has come right now. It is from Muhammad Nasif.
Okay.
Is this bathymetry data available for research or public now?
And that's why I just now I told it will be available in future. Yes.
Okay.
Yeah.
Thank you. So I think these are the questions. There are no more questions in the chat box.
Yeah.
So I think it's very good. So it was a very nice talk and quite informative. I'm hopeful that this talk will be appreciated by almost all the researchers actually working in this area. So thank you, Dr. Jena. And so on behalf of the Ocean Society, express my thanks for this wonderful talk. Thank you.
Yeah, thank you. And I thank also on behalf of Ocean Society of India, as I am General Secretary, meticulously without fail, you are conducting this program. And on behalf of GC OSI, I thank you very much. And so I may leave now. Yeah, thanks. Thank you.
Thank you. Thank you very much.